All right, welcome everyone. So I'd like again to start off with a pretty straightforward problem here. So we have a triangle like this. Here's triangle ABC. AB has been extended out to a new point D out here. So if CAD is equal to 61 degrees, let's say this is 61 degrees here, is it possible for AB to be perpendicular to BC? Why or why not? So again, take a minute, pause the video here, and see if you can solve the problem on your own. I think that's going to be really important here. Okay. Okay, so let's have a look at this, shall we? Well, let's see. Is it possible for AB to be greater than BC, AB to be perpendicular to BC? Well, let's see what happens. Well, the only thing we know is that this is 61 degrees, which implies that CAB here has to be 180 minus 61. So we can write that the measure of angle CAB here is going to be equal to 180 minus 61, and that is 119 degrees. Do I remember correctly? Okay. Now, we want this to be a right angle here. So some of you may note, wait a minute, there's no way this can happen, right? Because we see there's a 119 here, and there's a 90-degree angle here. If that's the case, these two sum up to 209, and it's already bigger than 180. No matter what it does sum up to, it's bigger than 180, so that's not possible. Okay, so I think that's pretty fair, right? I think we can just use the facts that we know of to show that this can't work. They just can't work. Okay, that's pretty fair. So clearly this cannot be 9 degrees. So can it be 70? Or 60? Or 50? Like, is there a threshold where we can switch over from where it can't be to where it can be? In theory, yeah, there should be a threshold here. And I think some of it comes as a result of this here. So we can do the same sort of calculation that we did here before and just kind of set it up that way. But we can also note there's another thing here to think about. Note that CAD here, right? This angle on the outside is an exterior angle, right? It's an exterior angle triangle. And one of our theorems is that the measure of angle of an exterior angle is equal to the sum of the two non-adjacent interior angles. So it's, in this case, angle C equals the measure of angle B here, right? So we have here, this is our exterior angle. And this is the non-adjacent interior angles. Now, we're assuming here that none of these quantities are going to be zero, right? So if we think about this here, this feels a lot like the partition postulate we looked at yesterday, right? We had a whole is equal to the sum of its parts. So we can apply that sort of version of the postulate here, where we can say the whole is greater than any one of its parts. So we can say that the measure of angle, so this will allow us to conclude that the measure of angle CAD should be greater than the measure of angle B here, right? So in this situation here, since CAD is 61, we know that angle B has to be any angle that is less than 61 degrees, intuitively, right? And notice that this works out really, really well, because this is a theorem that we've established already, a couple weeks back, and now we have our postulate that we can, our inequality postulate that we can apply to this here. So in fact, this is actually very easily proven. We end up with a new theorem here. So if a side of a triangle is extended to form an exterior angle, then its measure is greater than either of remote interior angle here. Sorry, ladies and gentlemen. So notice here again, the idea is that we were able to take our theorems from our standard geometry here, and we can turn them into a version that involves inequalities instead. So this setup is practically the same as the exterior angle theorem what we did with geometry before, with triangles. But now, instead of saying equal, we're saying greater than or greater than either. And this theorem happens to be a very important one. We'll take a look at this here in a bit. But keep this idea in mind, because we're going to be talking about this later on.